crazy project, man. Hands up, so cool. Is there any other questions? No. If not, I'd like to introduce the next speaker, which will be Sanjana. And her project is the Third Eye for the Blind, and she's become a bit of a soldering master with her project. And if you could take it away, Sanjana.
So, hi, as Sam said, my name is Sanjana. I am a rising junior at the Middlesex County Academy for STEM, and my project was the third eye for the visually impaired. So just to start off with a basic, what is it in general? As you can see to the picture to the right, it's just a glove that someone who is visually impaired can slip on. And the sensor at the fingers is a ultrasonic sensor, which I will get into later. But basically what it does is it detects the distance. And then using code inputted into my ESP32, I have attached a piezo buzzer and a vibrating motor along with two buttons in order to either switch between the piezo buzzer and the vibrating motor or to turn the project on and off. And what it does is, depending on the distance, the buzzer either beeps at a rapid pace if something gets closer, or the vibrating motor vibrates at a higher frequency for a shorter period of time as to alert the person that there is an object approaching. So first I'm going to give a quick demo, and then I'm going to go more into the different parts that I just mentioned. So to start off, I'm just going to slide on my glove here. So to start off, the project is in its off state. As you can see, my hand is approaching this, and neither the buzzer nor the vibrating motor is going off. But if I were to press this button right here, that will turn the project on. Oops, sorry, some technical difficulties. There we go. So now that the buzzer is working, as my hand approaches, it starts buzzing faster and faster. But let's say I'm in like a noisy setting and I can't hear a small piezo buzzer. If I press this button here, I don't know if you can hear that, but I can feel it. It's a vibrating motor, which is buzzing on my wrist, and my hand is still at the same distance, but you can't hear the buzzer. So now that the vibrating motor is there, this button basically switches between the vibrating motor and the piezo buzzer, and this button basically turns the entire project on and off. So now that you've seen how the project works, I would just like to go more into the actual way the parts work. So as I said before, there are four main parts to my project. There's an ultrasonic sensor, a vibrating motor, a piezo buzzer, and an ESP32. So the way an ultrasonic sensor works is one of those channels that you see is going to emit a sound wave, and then depending on how long it takes the second channel to absorb that sound wave using a specific formula, it can measure the distance that the object the sound wave is bouncing off of is. And then the way a piezo buzzer works is it uses a special crystal called a piezo crystal, which is a material that changes shape when different voltages are applied. So for my piezo buzzer, because it's a relatively small one, I only needed the 3 volts that is supplied by the ESP32. But the larger you go, it can go up to 9 volts or even higher, depending on how big your buzzer is. And if the crystal pushes against something, specifically the diaphragm of the buzzer, it creates a pressure that we, as in the human ear, picks up as the buzzing noise that you just heard. The vibrating motor works somewhat similarly. So since that motor, that circular disc that you see on that chip almost has a magnetic field, a force can be generated which causes the weight of that disc to move. And because it'll frequently be moving and displacing, the weight causes an unstable force, which we feel as a vibration. And finally, the ESP32, which is the brains of the project, it's my microcontroller. And before I inputted the code to it, and it's holding that code, and it's connected to a battery pack now in order to provide power, so it's fully portable. But what happens is that ESP32, as I said before, stores the code, and all my parts are connected to that ESP32, which is then going to output the code that I had previously put into it. Beforehand, I was using an Arduino, which works virtually the same way, except the ESP32 is a lot more smaller and more compact, which makes it easier to use for a portable project like a glove. So in terms of challenges of my project, the main challenge for me was actually soldering. So to the right, you can see a picture of what my finished solder board looks like. So this is actually the back of that green board that was in the center of the glove. And in the beginning, I had never soldered before, so this was an experience to say the least. I didn't know how to prep my iron properly, so that took a solid like 2 days to get through. But in the end, it got a lot easier. My tracks got a lot neater. As you can probably see, some of the tracks are neater than others. And I was able to successfully connect both buttons as well as a piezo buzzer to my ESP32 and make successful connections. My favorite part of this project was actually the coding aspect of it. So as someone mentioned before, Arduino code is very similar to that of C++, and I had done some side projects in C++ before. So while it did provide some familiarity to me, it still was somewhat new. So I was learning while still knowing some background information. I think one of the things I learned, especially between the difference from an Arduino and an ESP32, is that the ESP32 does not support the tone function of a piezo buzzer that the Arduino does. So it took me a while to figure out that I had to import a Tone32 library in order to get that tone function working properly with the new ESP32. So that's all that I have from my end. So if anybody has any questions, I would love to take them now.
I have a question. So soldering, I know is very difficult. What was like? Did you have any bugs with like the soldering besides like the tinning iron?
I did actually have a bug. So I think it was actually 2 days ago. Everything was working fine except my vibrating motor wasn't vibrating. And the reason for that was my soldering joint for that vibrating motor, it has 3 pins. So one connects to power, which was my VCC by 5 volts, one connects to ground, and then one connects to an input pin on my ESP32. So my ground connection and my input connection to the ESP32 are right next to each other, and there was a very, very, very small amount of solder connecting that input pin to ground. So instead of getting power, the whole vibrating motor was grounded. So I had to take my soldering iron with the smallest tip and just move it a little bit to the side, and suddenly it was working perfectly. And that was probably like the most nerve-wracking thing I ever had to do, just in case the wires fell out.
Yeah, it's definitely not fun when the soldering isn't working for you. Great. Does anyone else have any questions?
Not a question, but that was an impressive amount of soldering.
Yeah.
Like,
Thank you.
on that board.
I was actually going to emphasize, guys, it's not easy. The tracks are so clean on that.
Somebody who's never soldered before that is truly impressive.
Yeah, like it is very hard. Sanjana put in an amazing effort. It was crazy. Awesome. All right. Well, with no other questions from anyone else, we can finish up.